guys, it's V from AB Simplified, and today I will be solving infinite limits. So unlike normal limits, an infinite limit occurs when the x-coordinate of a given function approaches either plus or minus infinity. Once again, indeterminate forms do exist and include infinity over infinity and infinity minus infinity. Both of these cases signify that the function must be algebraically manipulated before the limit can be calculated. Most of the infinite limit problems you will be encountering will be in fraction form. That is, the function will have both a numerator and a denominator of two different polynomials. This case will usually yield the indeterminate form infinity over infinity. Manipulation is simple and involves dividing each term of the function by the highest powered variable. So let's say we have the following problem. The limit of 7x squared plus x minus 100 over 2x squared minus 5x as x approaches infinity. So if we begin by plugging in infinity for x, we get 7 times infinity squared plus infinity minus 100 all over 2 times infinity squared minus 5 times infinity. So simplifying this out, we know that infinity squared is infinity and anything times infinity is infinity. So 7 times infinity squared is infinity. We keep that plus infinity as plus infinity and we leave the minus 100 as minus 100. And the denominator becomes 2 times infinity squared is also infinity. And 5 times infinity is also infinity, so infinity minus infinity. So right off the bat, we see that the denominator has the indeterminate form, infinity minus infinity. So in this case, we must simplify this function down. So notice how it's also in a fraction form, and like I said, for infinite limit, when the function is in a fraction form, we must divide each term by the highest power variable, and in this case, that is x squared. So to manipulate this, if we divide each of these terms by x squared, we get the following. So limit as x approaches infinity of 7x squared over x squared plus x over x squared minus 100 all over 2x squared over x squared minus 5x over x squared. So simplifying each of these terms out, we get the limit as x approaches infinity of x squared here cancels out and becomes 7 minus x over x squared is 1 over x minus 100 over these x cancel out and becomes 2, and the 5x over the x squared becomes minus 5 over x. Now if you plug in infinity, we get the following. So plugging in infinity, we get 7 plus 1 over infinity minus 100 over 2 minus 5 over infinity. So if we simplify this out, we know that a constant over infinity is 0. So 7 plus 0, this minus 100 is also over x squared. So in this case, substituting infinity for here will make this 0, since any constant over infinity is 0. So then 7 plus 0 minus 0, and the denominator will become 2 minus, since it's the constant over infinity, 0. So in this case, the end result will become 7 over 2. So once again, all we did was we noticed that if we plugged in infinity for x originally, we got this form right here, and notice that infinity minus infinity is indeterminate form. So then we divided each term by x squared, and by doing that and by plugging in infinity, we get the following, 7 over 2. So this next problem also notices that it's in fraction form, and if we plug in infinity for x, we get infinity squared minus 3 times infinity plus 7 all over infinity cubed minus 10 times infinity minus 4. And if we simplify everything out, infinity cubed minus 3 times infinity is infinity minus infinity plus 7. And just off the bat, we notice infinity minus infinity, so without even calculating the denominator, we know that this is this will bring us an indeterminate form, and we must manipulate this function further on. So, since it's a fraction, we do the exact same thing. The highest powered variable is x cubed, so dividing each of the terms in the function by x cubed gives us this. Limit as x approaches infinity for x squared over x cubed minus 3x over x cubed plus 7 over x cubed all over x cubed over x cubed minus 10x over x cubed minus 4 over x cubed. Now, simplifying everything we can, we get 1 over x, since this cancels out, minus 3 over x squared, as this cancels out, plus 7 over x cubed, all over, this becomes 1, minus 10 over x squared minus 4 over x cubed, the limit as x approaches infinity. So in this case, this is completely simplified, and at this point, if we substitute infinity for the x's, we get 1 over infinity minus 3 over infinity squared plus 7 over infinity cubed over 1 minus 10 over infinity squared minus 4 over infinity cubed. And simplifying this out, we know constant over infinity is 0. So that's 0 minus 3 over infinity squared. We know infinity squared is infinity, and 3 over infinity is also 0. And same thing for this case, that would also be 0, since infinity cubed is also infinity. And the denominator, we keep the 1, and minus 10 over infinity squared becomes 0, and minus 4 over infinity cubed also becomes 0. So at the end, we get 0 over 1, and this equals 0. So once again, all we did, we plugged in infinity in the beginning, and we noticed that we got an indeterminate form. And then all we did was divide each term by the highest powered variable, and then plugged in infinity, and got 0. So this next problem is the limit of x minus the square root of x squared plus 7 as x approaches infinity. And notice that this is not actually this is not actually a fraction, so we have to figure out another way to manipulate this. But yeah, we have to find another way to manipulate this. And that's because if you plug in infinity for x, we get infinity minus the square root of infinity squared plus 7. We know that the square root of the infinity squared is infinity, and that infinity plus a constant is also infinity. So this equals infinity minus the square root of infinity. The square root of infinity is infinity, and this becomes the indeterminate form infinity minus infinity. So like I said, we have to manipulate this, and this is not in fraction form. So what you can notice is that a conjugate of this is possible, and the conjugate of this function is x plus the square root of x squared plus 7. So now, if we multiply this function by 1, but 1 as in the form of this, over the same thing, we may be able to get a function that is easier to handle. So let's try that. So if you multiply this function by its conjugate, we get x minus the square root of x squared plus 7 times x plus the square root of x squared plus 7 over x plus the square root of x squared plus 7. Remember, this equals 1. We will get, this will be equal to the limit as x approaches infinity of x squared minus the square will go away, so it will be minus x squared plus 7. And let's just keep the bottom since we don't want to mess with that. X plus the square root of x squared plus 7. So now if we simplify this out, you will get limit of, as x approaches infinity, of x squared minus 7 over x plus the square root of x squared plus 7. And canceling, making this equal to 0, we get this equivalent to the limit of, as x approaches infinity, of negative 7 over x plus the square root of x squared plus 7. So now if you plug in infinity, look what we get. We get negative 7 over infinity plus the square root of infinity squared plus 7. That's a squared. Sorry. So remember that. So if we start inside the radical and we simplify that out, we know that infinity squared is infinity. So we do infinity plus the square root of infinity plus 7. We know infinity plus 7, or any infinity plus a constant, equals infinity. So if we simplify this out, we get negative 7 over infinity plus the square root of infinity. We know that the square root of infinity is also infinity, so this equals negative 7 over infinity plus infinity. And notice how infinity plus infinity is not infinity minus infinity. And since it's two positive infinities being added together, the denominator equals positive infinity. So this equals negative 7 over infinity. And we know that any number over infinity, any constant over infinity, is 0. So at the end, the answer becomes 0. So once again, notice how by plugging in infinity originally for this, we got the indeterminate form infinity minus infinity. And notice how it's not a fraction, so what we had to do was multiply it by the conjugate, which is x plus the square root of x squared plus 7. And by doing that, we were able to manipulate it so that once we plugged in infinity, we would get a definite answer. So let's do one more problem. And notice here that when we plug in infinity originally, we get 3 times infinity cubed minus 1000 times infinity squared. And at this point, you should be able to tell that this equals the indeterminate form infinity minus infinity. And also notice that this is not a fraction, so we have to use some other kind of algebraic manipulation. And so in the last problem, we used conjugates, but I don't think conjugates will work that well since we have really high-powered variables. So in this case, notice how that you can factor out an x squared from both of these terms, and if we do that, we get the following. So we get the limit of, as x approaches infinity, of 3x cubed minus 1000 x squared. If we take out the x squared, we get the limit as x approaches infinity of, got the x squared, we got 3x minus 1000. So at this point, we can't do anything. But if we plug in infinity for x, we get infinity squared times 3 times infinity minus 1000. And using our infinity rules, we know that this infinity will be equal to infinity. The infinity squared will be equal to infinity. And the 3 times infinity will be infinity. The negative 1000 will stay the same. Infinity minus 1000 is again infinity, so it will be infinity times infinity. And notice how there's no rule stating that infinity times infinity is an indeterminate form, and since both infinities are positive, the answer to this will become positive infinity. And yep, that's it. So all we did was we plugged in infinity, we noticed the indeterminate form, we factored, and then we plugged in. So notice how there's 3 different types of way to actually manipulate the function. For the first time when we had a polynomial, we divided each term by the highest power variable. The second time we used conjugates, and the third time we just factored.